Hello, this video is on functions. Specifically, it's the second of two videos on quadratic models. To find the equation of a quadratic model, one of two methods can be applied. Method 1, a system of equations, where we will solve simultaneous equations with three unknowns. Or method 2, quadratic regression, where we will find the equation of the regression curve. In this example, to find the equation of the quadratic model using a system of equations, we need to identify 3 points on the curve. There's one, there's the second one, and there's a third one. Substituting these three pairs of coordinates into the function f. So for the first point, replacing x with -1 and equating it equal to 0. For the second point, replacing x with 0 and equating it equal to 3. And for the third point, replacing x with 3 and equating it equal to 0. Simplifying the equation leads to three equations involving a, b, and c. To solve this system of equations, from the main menu, select Equation. Press F1 for simultaneous equations, and then press F2 for three unknowns. Enter in the coefficients of the three equations. So for the first equation, that's 1, -1, 1, and 0. For the second equation, it's 0, 0, 1, and 3. And for the third equation, that's 9, 3, 1, and 0. Then pressing F1 to solve this system. We see that the value of A is -1, the value of B is 2, and the value of C is 3. So the quadratic model is f of x is equal to -x squared plus 2x plus 3. In method 2, to find the equation of the quadratic model using quadratic regression, again we still need to identify 3 points on the curve, but this time we enter them into lists on the calculator. From the main menu, select Statistics and enter the x coordinates into list 1. So that's -1, 0, and 3. And then use the right cursor to get to list 2 and enter the y coordinates into list 2. So that's 0, 3, and 0. Then pressing F2 for a calculation, and F3 for regression, and F3 again for an x squared regression, a quadratic regression. Again, we see that A is -1, B is 2, and C is 3. And the quadratic model is f of x equals -x squared plus 2x plus 3, as before. In this question, we're asked to find a quadratic model for the lower span of Sydney Harbour Bridge, as shown in the diagram. If we begin by identifying 3 points on the lower span. The lower span passes through 0, 0, 251.5, 118, and 503, 0. To find the quadratic model using quadratic regression, if I just press exit, then I get back to the main menu, entering the x coordinates into list 1, so that's 0, 251.5 and 503. Moving across to list 2, entering the y coordinates, so that's 0, 118 and 0. Pressing F6 to get back to the main menu, so I can press F2 for calculation, F3 for regression, and F3 again for a quadratic regression, given the values of A, B and C as shown. So the quadratic model for the lower span is f of x is equal to negative 0.00187 x squared plus 0.938 x. In part A of this question, we're asked to write down 3 equations that can represent the model, identifying 3 points that lie on the path of the ball. So the ball passes through 10,9, 20,15.25 and 30,19. Substituting these values into the model, simplifying these equations gives the following system. And by system, I mean set. In part B, to find the model connecting H and D, from the main menu, select equation, then F1 for simultaneous, and F2 for 3 unknowns. Pressing F3 to clear the previous information, we can now enter the coefficients of the equations. So for the first equation, that's 100, 10, 1 and 9. For the second equation, 400, 20, 1 and 15.25. For the third equation, 900, 30, 1 and 19. Pressing F1 to solve the system gives us the values of A, B and C as shown. So the model is H of D is equal to negative 0.0125 D squared plus D plus 0.25. In part C, to find the maximum height reached by the ball, we need to find the vertex, or the maximum point. From the main menu, selecting graph, typing in the equation of the model to y1. So that's negative 0.0125, pressing the x variable and then the square button, plus pressing the x variable button again, plus 0.25. Pressing execute to enter the equation. Pressing shift and then F3 for view window. Setting x min to 0, x max to 80, and an x scale of 10. Setting y min to 0, the y max to 25, and the y scale to 5. Pressing execute and then F6 to draw the graph of the function. Pressing F5 for gsolve and then F2 for a maximum point. We see that the maximum value of the function is 20.25. So the maximum height reached by the cricket ball is 20.25 meters. In part D, we're asked whether the ball will clear the fence, which is 1 meter high and 75 meters away. So we need to find h of 75. Replacing d with 75 gives a value of 4.9375 for h. Alternatively, we can use the calculator to solve this problem. Pressing F5 for G-solve, and then F6 to get to the next page of menus, and F1 for a Y calculation. Entering the value of x as 75, and pressing execute. Again gives a value of h equal to 4.9375. And since this value is greater than 1, which is the height of the fence, then yes, the ball will clear the fence.